Hello everyone and welcome back. So now we're in example 2.8, flying through these. So let's see what it says. Okay, so we have a block having a mass of 400 kilograms and oh boy, is this a different one. 400 kilograms. It rests on an inclined surface. It says determine the components of gravitational force exerted on the block perpendicular and parallel to the inclined surface. Now this might seem hard, but it really isn't. It's not that hard at all. So the biggest thing you need to know right now is, first off, 400 kilograms, that is mass, not weight, okay? Kilograms equals mass. We want weight. If we want weight, we've got to multiply it by 9.81. So weight is equal to mass times gravity, which would be equal to 400 kilograms times 9.81. Your book says 9.8 and they're terribly wrong. Keep it to 3 sig figs. 3 sig figs. And for this one, it looks crazy, and then you just turn it on its angle, and guess what? Suddenly, it's not so crazy anymore. Okay? That's just 5 degrees. I can't draw that to scale because it's just too small of a angle. And boom, I have everything I need. So let's try it out. First up, we're going to use M to determine the value of W. Remember? Weight equals mass times gravity. That's another equation that you should probably memorize. I plug it in. 400 kilograms times 9.81 meters per second squared. It's going to come out to be 3.92 kilonewtons. It technically comes out to be 3,920 newtons, but just to make it sound nicer, I say 3.92 kilonewtons. If you're wondering where the newtons came from, a kilogram meter per second squared, that's a newton. Okay, now if I know W, I know the angle, and I just use my trig functions, just like always. So if I want to, I can use this triangle down here that they've made for me. I can also draw my own if I wish. Use whatever makes sense to you. So in this case, where you seem to be using the angle 5 degrees rather than the bigger angle, because you see right here that I've marked WY as adjacent instead of opposite. And it's all going to depend on what angle you decide to use, okay? You can use either one, just make sure that you name your sides correctly. Since I'm using 5 degrees, WY is adjacent. If I had been using the 85 degrees, well then WY is opposite 85 degrees. The adjacent side is the side that is touching the angle. The opposite side is the one that's kind of like the base of the triangle if your angle is the point. So I plug it in here, and I get 3.92 kilonewtons times 5 degrees. And you see I added a negative sign here. I did that because it's pointing in the negative x direction. I always consider down to be negative, up to be positive, right to be positive, and left to be negative. And I use my trig function once again to find the other. And so you see here, since I'm using 5 degrees, and I'll redraw this, make it a little bit simpler. There we go. So I'm using this 5 degree angle. Well, what's the side that's the base? Well, this is the base. That's opposite. And it also happens to be WX. And so opposite of our hypotenuse is WX over 3.92 kilonewtons. I do sine of 5 degrees and I get, okay, this is going to be 0.342 kilonewtons. 0.342 kilonewtons. And be very careful with your signs here. This should come out to be positive because it's pointing in the positive X direction. Well, I hope this was enough practice to really get you running with these components and with the resultant of adding together these components. Please practice your trig. You're going to need that help as we go further forward. And thank you for listening. Have an absolutely wonderful day. Bye-bye.